In this last video, we will see the backpropagation algorithm by putting all the steps together. Let us start with the first step. In the first step, we will be setting the delta ijl to 0. This is for all L, I and J. If you observe this delta ijl, this is the capital delta. What we used in the previous session, that was the small delta which we used to calculate the error of each layer. While we were calculating the errors, we used the backpropagation method. This is the first step which you have to perform by setting the 0 for all the delta ijl, and this is initializing of delta ij. After that, you can start a loop which will start with the 1 and will be there for m. As you remember, m refers to the number of samples you have in your data set. In that, you are starting by setting a1 is equal to x of I. This is basically to make sure that your first layer is your x, that is the input layer, and that is the feature layer for your neural network. After setting the first layer, the next step is to perform forward propagation to calculate a of L, where you have L is equal to 2, 3 up to L. The capital L here refers to the number of layers, and we are starting from the second layer, and we will be calculating the A of L for all the layers. We are not calculating the A of L, that is activation function, for the first layer, because our first layer is the input layer. That is the reason why we have started by the number 2. In the next step, you have the y of I available with you. You have to calculate delta of L is equal to AL minus y of I. This is the same formula which had been used in the previous video, where we calculated the error of a particular layer. Here L refers to the layer number. Here we are calculating the L, that is the last layer. So what you had in the previous example for delta 4 was this formula, AL minus y of I. After having the delta L, that is the error in the last layer, now it is time to calculate the errors in the remaining layers. So you will be starting in the reverse order from delta L minus 1, L minus 2 up to delta 2. So in previous example, we calculated the delta 4 first, and then we calculated delta 3, delta 2, and finally we did not have any other layers, so we stopped at delta 2. But again, you don't need to calculate the error for delta 1. Based on the number of examples you have, you keep updating your delta ijl by setting it with the value you get for the delta il plus 1. This is being done to find out the value of delta ijl, which is required in our gradient descent calculation. Let us move to the next step after coming out of the loop. The next step is d of ij. Now we are simply using another term because we have already used small delta and capital delta, but still we are working on the error and the differences, so we will be using capital D here. For dij is 1 upon m delta ijl, which was derived earlier, plus the lambda theta ijl if j not equal to 0. If your term is 0, if you have j is equal to 0 as shown here, the parameter which is added, the regularization term, is no more required, and you have delta dijl is equal to 1 upon m delta ijl. After deriving dijl, you can simply say that this is nothing but this is your derivation of theta ij for the cost function j of theta. It looks little tricky and complex to understand, but if you go in the proper systematic fashion by calculating the forward propagation and then by calculating the back propagation, and then simply you have to concentrate here where you are putting up the things and finding the capital delta and d, which becomes your derivative terms for the cost function j theta. So this is how the steps can be achieved, steps can be followed to achieve the final result, which is nothing but your derivative for j theta. And next slide we will see all the steps in the statements. So to begin with a neural network problem, first thing is to, of course is not mentioned here, but the first thing is to find out the architecture or decide the architecture, how many hidden layers you want, and what will be the features, what will be the expected outputs and other things. But assuming that all those steps have been completed, the first step is to do the random initialization of the weights which are being used in the form of theta for connecting the neurons of layer 1 to layer 2 and so on, have to be initialized randomly, because you cannot start with the zeros or ones as your initial theta and then you can simply cannot proceed. Otherwise, in that case, you will be having layer 1 values is equal to layer 2 and layer 2 values will be equal to layer 3. After initializing the weights with the random values, the next step is to implement forward propagation to get the h theta of x of I for any given x of I. So it's nothing but it's simply completing the forward propagation method for achieving the final values of the output layer. Then you can calculate the cost function as discussed in one of the videos. And the fourth step is to implement backpropagation to compute partial derivatives, where you first calculate the small delta of each layer starting from the last layer L and then moving backward for the L minus 1, L minus 2 up to the second layer, and then putting them into the capital delta IJL, and then finally having the capital D notation to get the derivative of j theta, that is the derivative of the cost function. And at the end you can use gradient descent or any other equivalent method with the backpropagation to minimize the cost, that is to minimize the j theta, and then finally you get the model which works best and which fits the best for your requirement. So here we end the neural network part, the topic related to neural networks. Thank you.